Let's now take different approaches to describe the NCS 5500 series and at the same time answer frequently asked questions from the customers. We start with the ASICs and the bandwidth. You heard me saying Jericho, Jericho Plus, but what are they exactly? The Jericho NPU offers 720 gigabit per second of fabric interface and 900 gig to the fabric. Whether it's used with or without eTCAM, it can treat packets at 600 or 720 million packets per second. This eTCAM is from NetLogic and offers 2 million extra IPv4 routes for the FIB. The Jericho Plus improves bandwidth and TPS with 900 gig for the network and 1200 gig to the fabric and 835 million packets per second. Broadcom has multiple flavors of them, and we are using two different kinds with different type of internal memories. And you can see the different LPM boxes here. Note that we are using a different eTCAM this time compared to Jericho. It's called Optimus Prime and it offers more than 4 million extra IPv4 routes for the FIB. For the system-on-a-chip platforms based on standalone architecture, we have different Qumran ASICs, and we are using the Qumran-MX only in the NCS 5500 family. The others are used in NCS 560 and 540 respectively. As you can see, the Qumran-MX is very comparable to the Jericho ASIC, just without the fabric links. Also, you notice that all these ASICs, Qumran-MX, Jericho and Jericho Plus, are very similar in terms of internal architecture. Same buffer size, same internal resources, etc. The only noticeable difference will be the type of external eTCAM, NetLogic for the Qumran and Jericho, and Optimus Prime for Jericho Plus. Last year, we made an addition to the list with the introduction of the products based on Jericho 2. From a product marketing perspective, that's the line cards and systems we are now identifying with the PID starting with NC57 or NCS57. The Jericho 2 is a very powerful ASIC made of 2 cores, same ingress and egress pipeline logic, but with some important improvements in terms of packet buffering and internal resources. The SerDes are designed to support 50 gig links encoded in PAM4 instead of the 25 gig in NRZs that we had before, so they are made natively for 400 gig interfaces. Also, they are coming with a new version of the external eTCAM, OP2 for Optimus Prime 2. It does offer a higher scale and potentially can be used for statistics on top of routes and classifiers. Comparing PPS and bandwidth with former generation, you will see in this diagram that J2 offers 6 times more bandwidth than a Qumran-MX, but at the same time it provides less than 3 times the amount of PPS. Logically, the NDR, the minimum packet size you can reach at max bandwidth, will be higher. The average internet packet size on internet keeps growing since we have more and more video. So it's the kind of trade-off that they made when they were designing the chipset. On the buffer side, we still have a hybrid model with both internal and external packet memory. Internally, the buffer size doubled compared to Jericho and Jericho Plus. Now we have 32 MB. For external buffer, we no longer use graphical DDR5, but instead HBM for high bandwidth memory, directly connected to the chipset via an interposer. The main benefit of this approach is we don't consume links to connect to the memory, and we can offer a higher bandwidth in total. This HBM is 8 GB large and is shared between the 2 cores. Another significant improvement compared to the Jericho first generation is the internal database allocation. Instead of dedicated memories of fixed size, we now have a big memory pool we can carve based on the role we want to address. It's not dynamic, but at the boot up, the system will allocate a portion of this MDB, modular database, for each memory type. So you can decide to get more scale for MAC addresses if you want to be an L2 VPN box, or more V4 and V6 routes if you want to address the L3 VPN edge routes. Okay, we'll come back on Jericho 2 in a few minutes, particularly to discuss the concept of compatibility and native mode. But now we can start browsing the portfolio and sort the routers based on the ASICs they use, and also the bandwidth they offer. It goes without saying, that's why I'm saying it, that bandwidth expressed here is always bidirectional and full duplex. We are not playing that game of adding input and output bandwidth to come up with some appealing number. So when I say 800 gig per second, I mean 800 in, 800 out. And 800 gig is indeed the bandwidth a Qumran-MX can support, at 600 or 720 million packets per second. The difference in performance here is due to the presence, or not, of a NetLogic external eTCAM. In our portfolio, only the NCS 5501 and 5501SC are based on this chipset. The SC version offers 40 ports SFP and 4 ports QSFP, and the non-SC port density is slightly higher, 48 SFP, 6 QSFP, which exceeds the 800 gig capability of a Qumran-MX. That's why we talk about oversubscription here. The Jericho ASIC is more vastly used on these routers. Each NPU can forward 720 gigabit per second at 600 or 720 million packets per second. We will need multiple Jericho ASICs in these systems and line cards. Most of the time they will be used at 600 gigabit per second. We have them in NCS 5502 SC and non-SC, but also 6 different line cards. The 36 port 100 gig non-SC with and without MACsec, the 24 ports 100 gig SC, the 2 combo cards offering a mix of 40 gig and 100 gig, and finally this 6 ports CFP2 IP over DWDM, the coherent optical line card. On the Jericho Plus side, we have a relatively faster NPU offering 900 gigabit per second instead of 720 in Jericho, and at 835 million packets per second. It will be the same performance, PPS, whether we use it with or without OP external eTCAM. We differentiate 2 categories, the J Plus with normal LPM side and the J Plus with large LPM. The first category powers the 55A124Q6HS, all the variant of 55A2 modes, and the 55A136H SC or not. Also, we can find it in the mode line cards and the 36-port 100 gig SC. If you remember the former slide, we needed 6 Jericho NPUs to offer 36 100 gig ports in a single line card. With so many NPUs on the board, we didn't have the footprint and the cooling capability to add external eTCAM. Jericho Plus is not usually faster than Jericho, but still it can handle 9 ports 100 gig per NPU. So we just need 4 of them to get to 36 ports. And that gives us room and heat exhaustion capability to add this new generation of external eTCAM. Only 2 systems today are using the large LPM version of this Jericho Plus ASIC, the 55A148Q6H and the 55A124H. Both are using them in back-to-back design internally. If the 48Q6H is not oversubscribed from a bandwidth perspective, it's not the case for the 24H. By the way, I would like to quickly comment on the oversubscription aspect. I know that certain persons are very picky about it, but it's usually not that important in real life. The situation where you will operate a system with all the ports pushing line rate traffic, flat and constant, are extremely rare in production networks. First, because of bursty nature of the traffic and the TCP windowing mechanisms, but also because you are probably experiencing a lot of packet drops if you have one port at 100 gig. So the chance to get the same situation on all the ports at the exact same time, I call it a lab stress test. Finally, we are shipping these 2 line cards powered by Jericho 2, the NC57 24DD and 18DD SC. Each Jericho 2 can forward 4.8 terabit per second, but on the SC version we will only use it at 3.6 because we are completing it with an OP2 external eTCAM. DD represents the QSFP DD optics that we use for 200 and 400 gig Ethernet. Now let's take a few minutes to describe these 2 new line cards. Very important, you need to upgrade the fabric cards and the fan trays before inserting these line cards in the chassis. So you'll need to have V2 fabric and fan in the chassis. Today we have them in the price list for 8 and 16 slot chassis, and later on this year we will ship the 4 slot version. These first line cards offer 24 ports QSFP DD, all of them 400 gig capable, for a total of 9.6 terabit per second. They are slightly longer than the Jericho line cards, but it was already the case for the coherent, and with the same motivation. The cooling of these optics is challenging and it will require specific adaptation of the form factor. Internally, the 24DD is made of 2 Jericho 2s, each one servicing 12 ports 400 gig. This line card is not equipped with external eTCAM. It's important to mention that internal resources in J2s are large enough to handle full internet views and with a lot of margin. so these cards can be used for peering jobs. The card name is 18DD, so you will expect 18 ports QSFP DD support for 400 gig optics. That's the case, but it's a bit more subtle. If you take a look at the front, you see 30 ports, but they are not all the same. The ports 18 to 23 can support 400 gig optics with no restriction, but they can also support lower speed like QSFP28DD at 2 by 100, QSFP28 for 100, and even QSFP Plus at 40 gig. The other ports of the cards are slightly different. In that sense, they need to be considered by pair, N and N+1. Each pair of ports is behind what we call a 400 gig cage. They are connected through a reverse gearbox. If you have QSFP 56DD and a 400 gig optic in position N, the position N+1 should be disabled. Also, you can have 2 by 100 gig in N and another 2 by 100 gig in N+1 for a total of 400 gig. That way, you can actually offer 60 ports 100 gig on this line card. And today, it's the most common use case for customers who deployed it. In this block diagram, you will find what I just explained. Port 18 to 23 are directly connected to the chipset, the Jericho 2, while the others are connected via reverse gearbox. Each RGB supports 400 gig. For your reference, this chart is summarizing the ASIC type, the bandwidth available, and the potential oversubscription for each fixed platform, and also line cards. Let's take another perspective to classify the systems, the presence of eTCAM to extend the scale. This memory should not be confused with the packet buffers. We only store information, data, in this eTCAM, not packets. They can be used for route scale extension to store access list info, and in the latest generation for statistics. Depending on the ASIC type, you will use different kind of external TCAM. Again, it's very easy to identify systems and line cards equipped with it, simply based on the product ID with the -SC at the end. With the first generation, Qumran-MX and Jericho, we used a NetLogic eTCAM. We had some specific limitations. For example, the NPU frequency was reduced to 600 million packets per second instead of the 720, just for the route lookup. Also, using features like URPF, you will need to disable the double capacity mode, reducing the scale to 1 million IPv4 routes instead of 2. That needs to be done via hardware module profile configuration. When configuring an hybrid access list, it's mandatory to allocate a certain percentage of the eTCAM, and here again, it will require a specific hardware module profile config. On this chart, you have an exhaustive list of the systems and cards using eTCAM. It shows the type of eTCAM and, just for reference, the extra scale it offers for IPv4 prefixes. You'll notice that OP and OP2 scale are the same, but in reality, an OP2 is much more capable than an OP, which itself is not limited to 4 million routes. So we are not using it at the maximum of its capacity. We can go higher than 4 million if needed. It could be done if we have enough demand from the customers. Let's try to answer the question, which one should I use if I need a full internet view? And to answer it, it's necessary to understand where we store the routes in the system. And it was a big part of the early CiscoLive breakout sessions we had on NCS 5500. But now things are getting simpler and simpler, and we will see that why in a minute. First, I believe it's necessary to state the obvious, since I still see the confusion multiple times a year. If you have 10 different internet tables coming from 10 different transit providers stored in the same VRF or global routing table, it will not be programming 10 times in the FIB. You will not have 8,500,000 routes. Actually, the FIB size will be slightly larger than one given table because some routes will be more specific from different transit providers, but more or less it will be one internet view and 10, 20 additional person max. So where does FIB goes exactly inside the box? The routes are stored in 2 or 3 places, the third one being optional. First, the LPM. Longest prefix match database is a memory where we can perform variable length lookup. For example, if we have a packet targeted to a specific destination, it will go over the tree to find out if the route is present /23, then it will go to /22, 21, 20, etc. Second, the LEM for large exact match. As the name implies, we are performing a lookup for a specific route and prefix length. Depending on the system, we'll have more or less capacity on the LEM or the LPM. Basically, except if you are using what we call a large LPM Jericho Plus, the LEM will be more or less twice the size of an LPM for IPv4. So we need to distribute the routes as smartly as possible to optimize the occupation of these resources of different capacity. The third memory is the external eTCAM, and of course this one is optional. It's limited to the SC systems and the line cards. LPM memory is algorithmic. That means the capacity is directly dependent on the prefix length distribution. That's why you will often see a range of values to express a scale. It's usually the worst case and an estimation based on internet distribution. In this example, for large LPM Jericho Plus, you will see the system estimates a capacity of 1.6 million routes instead of 1 million that we advertise on the Cisco website. For typical Jericho and Jericho Plus, the LPM capacity will reach more or less 350,000 IPv4 routes for internet. So, depending on the system we pick, we'll have a different logic to store the routes. Also, it can be influenced by the configuration, as you will see now. We'll have 4 different cases with 2 options in the first one. First case, Jericho and Jericho Plus, but no eTCAM. That's the kinds of line carded systems you will select if you have a BGP-free core, LSR roles where you don't need millions of routes. These are the systems powered by Jericho, and now those with Jericho Plus. The same logic applies to both of them. For IPv4 prefixes, you can store 768,000 on LAM and up to 350K on LPM. If you don't change the default configuration, the logic is the following. IPv4/32 and 24, IPv6/48, MAC addresses and MPLS labels are stored in LEM. The rest will go to LPM. That means v4, v6 and multicast entries. And it's a smart thing considering that IPv4/24 and IPv6/48 are the larger route population in the internet table. 3 years ago, we had customers who didn't want to invest in systems with eTCAM, still they wanted to program full IPv4 and IPv6 views, so we created specific optimization to organize the routes differently, no longer giving precedence to v4/32, and to make the best possible use of LEM and LPM space. So that's the Internet Optimized mode. Today, in the middle of year 2020, I discourage you to use this approach. Actually, we plan to remove it from the configuration in 7.3.1 and 7.4.1. The first release will provide a warning message if you try to commit it, and the second will simply remove the code dedicated to this feature. Internet is just too big now. Let me show you why we don't recommend these line cards with current internet distribution. I took a snapshot of the internet size in early 2020. On this particular autonomous system, we can see 835,000 IPv4 prefixes and 80,000 IPv6. With the default host optimized mode, it's already exceeding the LPM capacity. With the Internet Optimized mode, we are getting dangerously close to the limit. That doesn't even count what you have in your IGP or MPLS or multicast. My recommendation is simple. Just don't use systems without eTCAM or without large LPM if you need to route the full internet view. For the second use case, I will consider a Jericho Plus without eTCAM, but with large LPM. Today, only 2 fixed systems are equipped with these NPUs, the 55A124H and the 48Q6H. If you consider an IPv4 capacity of 1.5 million prefixes in LPM, added to the 768,000 routes in LEM, we can handle internet with no issues. The same recommendation applies now. Don't use an Internet Optimized mode, since the LPM is twice the size of LEM, and no longer the opposite. Actually, with the current internet growth rate, we will probably recommend to disable the IPv4 host optimized mode that is used by default. With host optimized mode, we have /32 and /24 going to LEM and the rest to LPM. Considering the current IPv4/24 size and growing speed, it may become interesting to move this route to LPM instead of LEM, something you can do with this hardware module configuration. Third case, we consider systems with Qumran or Jericho MPU with NetLogic eTCAM. Here, we will use eTCAM for all IPv4 routes except the /32s. We will use LPM for all IPv6 routes except the /48s and the multicast groups, and we will use LEM for IPv4/32s, IPv6/48s, and MPLS labels and MAC addresses. Finally, case number 4, Jericho Plus with Optimus Prime eTCAM. and actually this last case covers the Jericho 2 with OP2 eTCAM also. It will be very easy here. We store all IPv4 and IPv6 routes in external eTCAM. We demonstrated that we program and remove routes faster in this eTCAM memory than in LEM or LPM. So it's a no-brainer. It's easier to implement, simpler to troubleshoot, and faster to program. Note that we don't need to configure anything for URPF. It doesn't reduce the routing scale because we have quite a lot of margin. And the same thing for hybrid access list. It's not necessary to allocate a specific space. It's done automatically and doesn't impact the routing scale either. Just for your reference, a chart summarizing the global capability of each system and line card. To quickly compare the capabilities of each option, I created this chart for IPv4, but keep in mind that the routes are not magically perfectly thoughted between these different resources to occupy the space ideally. So take it for what it is, it's just a capability. Key message for IPv4, you need large LPM for your Jericho Plus, or you need external eTCAM to support a full internet view. For IPv6, things are probably a bit more complicated to apprehend. Jericho with and without eTCAM will be the same, simply because we don't store IPv6 prefixes in eTCAM by default. But it can be changed by configuration if we want to. Then, you may think that Jericho Plus with large LPM is the same scale than Jericho Plus with eTCAM, but it's not entirely true. It will be the case if the routes were perfectly balanced to occupy both LPM and LEM completely in the first case, while they will be all stored in eTCAM on the second one. Also, keep in mind that internet size for IPv6 is fairly small today, around 80,000 routes, so it's difficult to make projection of growth to millions. That's why we have this dotted box here. Long story short, if you don't want to take any risk and make sure you can change your mind and push multiple times internet in the routers in the future, it's always the safe approach to pick a Jericho Plus based system with eTCAM. Let's now talk about ports and answer typical questions like, can I use 25 gig here or breakout cable? And we'll start with the highest bandwidth, 400 gig, describing all the options down to the lowest speed, fast Ethernet. One word before I start. For all the ports I present here, and if I don't mention it specifically, the supported framing is LAN PHY. So if I don't say anything, that means we don't support Wi-Fi or OTN framing on these ports. One side to bookmark, the TMG matrix. TMG is a group handling all the optics in Cisco. With this site, you know very quickly what is supported, the minimum software release you need, the media type, the connectors, etc. It's a fantastic resource. Which products can give me 400 gigabit Ethernet ports? We spent some time on this card already. Today it's only the NCS55 line cards, the 24DD and the 18DD SC. Which NCS5500 router should I use for 100 gig Ethernet ports? It's fair to say that NCS5500 platform has been optimized for 100 gig Ethernet. On the fixed platforms, I see two main situations. First, I need 100 gig as uplink to aggregate lower speed ports. For this task, I can use the 5501 SC with 4 ports QSFP28 and the non-SC version, that's going to give me 6 times 100 gig, same quantity of 100 gig ports for the 55A1 24Q6HS and 48Q6H, and in the NCS55A2 mode, it will depend on the MPA inserted. I can plug 2 of them, and at best, it will give me 4 ports 100 gig each, total 8 times 100 gig. But also we have platforms with exclusively 100 gig ports, like the 55A1 24H, offering 24 ports, the A1 36H, 36 ports, and the 5502, that's gonna give me 48 ports. On the line card side, it's fairly easy. Most of them are offering QSFP ports. 2 points to mention maybe. The mode line cards are also using the same MPA I mentioned earlier to get 100 gig connectivity. So be careful, the 2 fixed ports on the right are 40 gig, not 100 gig. The second comment will be related to the combo cards, you know, the 18H, 18F and 24H, 12F SC. These cards are a bit special in the portfolio. In that sense, they are offering 36 port 40 gig by default, and you need to use licenses to upgrade some of the ports from 40 gig to 100 gig. On the first one, you can upgrade half of the ports. On the second, it's going to be 2/3. These line cards have been very popular to smoothly migrate from 10 gig to 100 gig backbone, starting with 4 times 100 gig breakout and slowly replacing the optics from QSFP Plus to QSFP28. I pretty much answered the question already. Which platform supports native 40 gig Ethernet ports? It's easy. All the QSFP ports I described in the previous section can be used at 100 gig but also at 40 gig if you insert a QSFP Plus optic. It's valid for both LAN card and fixed systems. On the combo cards, some of the ports can be used at 40, and it's the same for the last two ports on the right of the mod LAN cards. I don't think 40 gig has been much popular in the SP world, but nevertheless, the support is here if you need it. In the other hand, the QSFP Plus with Breakout offering 4 by 10 gig has been widely used. Which NCS 5500 router should I use for 25 gig ports? We have seen a clear trend on the market towards 25 gig interfaces, top of rack and cell site aggregation mostly. So it's clearly a thing now. 3 routers in the portfolio support SFP28 optics natively. The 55A2 mode, we have the 16 fixed ports on the right that can be used, and they are identified with a yellow color in the front. Also, we have the 24Q6HS, the 48Q6H supporting 25 gig on half of the SFP ports for the first one, and all of them for the second. Note that we can also break out 100 gig into 4 times 25 gig on some other products, but there is some limitation that I will list in a minute. We have a section dedicated to the breakout. Which NCS 5500 should I select for 10 gig connectivity? On the fixed system side, all the boxes offering SFP ports can of course accept SFP Plus optics. That's the 55A1 and SC, the 55A1 24Q6HS, and the 48Q6H. Only the mod LAN card can offer SFP ports. 12 fixed on the LAN card itself, and then twice 12 ports on the MPAs. So in total we have 36 native SFP ports. If you need 1 gig in SFP optics, it will be the same thing. But the only difference will be for the 12 ports MPA. In this MPA, the 4 ports in the middle, from 4 to 7, cannot be used at 1 gig. Another particular case, an exception, are the ports 4 to 7 in the NCS 5501 SC. We don't support AutoNeg at 1 gig optical SFP on this one. And finally, if you need 100 megabit per second fast Ethernet, and I know it happens, we have just these two options, 5501 and SC, and 55A2 mode, but only on the fixed ports and not on the MPA. Regarding the 5501 SC specifically, some ports highlighted in red here cannot be used with the copper version of the optic, the GLCT. Okay, we covered all the native ports options from 400 gig down to fast Ethernet. But what about Breakout? It can be an interesting option, but I know some people don't like this approach because it requires additional wiring work with patch panels, etc. Nevertheless, at some point we cannot offer connectivity with native ports simply because of the space we have in the front of the LAN card. And Breakout is the only possible approach to offer more ports. You can use 400 gig QSFP DD port and break it in 4 times 100 gig, but keep in mind that you cannot do that with 100 gig SR4, LR4 or CWDM4. It's gonna require a specific 1 lambda 100 gig optic, like the QSFP 100 gig FRS. Indeed, you have on the left a 400 gig port made of 4 lambda of 100 gig each, and using a PAM4 encoding scheme. If the facing 100 gig port is made of 4 lanes of 25 gig using NRZ encoding scheme, they just can work together. So 1 lambda 100 gig with PAM4 is the way to go. FR is available today, LR is coming. If you are rolling out a 100 gig deployment today, it's highly advisable to consider 1 lambda QSFP to prepare future connection to 400 gig Breakout. Now, if you need to connect to your existing 100 gig SR4, LR4 or CWDM4, it can be done, but with a QSFP2 ADD and just 2 by 100 Breakout. If you remember, the 30 ports Jericho 2 LAN card I presented earlier, it offers 30 ports that you can populate with this 2 by 100 Breakout optics. That's going to make it a 60 port 100 gig LAN card. And you can connect it to the vastly popular standards that are SR4 and LR4. We can also break out QSFP28 optics into 4 times 25 gig, but it's only supported on Jericho Plus systems. That's why it's so important to understand the MPU type powering each router. Also important to notice that we don't support today a breakout to LR, it's only SR. 4 by 10 gig breakout is supported pretty much everywhere except with the SRS. Every time you have a QSFP port, you can insert a QSFP plus optic and breakout to 4 times 10 gig. One more time, I invite you to take a look at the TMG matrix page and you will have the latest information. If you only have QSFP ports in your system and you need to connect one or few SFP ports, we have a solution in the form of a MIDI adapter called QSA. It's actually a more common use case that you may think. Even if you burn 90% of the port capacity with an SFP plus optic, or even 99% with an SFP, you may want to do that to avoid the addition of an intermediate system that you will need to operate and manage. That's one more management IP address, one potential additional point of failure, another operating system and release to validate before insertion, etc. Also, you may need a longer reach punctually, like 80 kilometers, at the expense of the bandwidth. QSA means QSFP2 ACO adapter, and it supports 10 gig and 1 gig. It works with most of the systems and line cards with the following noticeable exceptions: the combo line cards 18H, 18F, the MACsec line card, and with the fixed systems 55A1, 36H, and 5502, we only support specific SFP optics, but it's mostly a testing effort. I will conclude this section with the last category of optics we support on NCS 5500 family, the CFP2. They are used for IP over DWDM coherent systems and line cards, and we support 2 different types of them. On the left, we have the CFP2 ACO for analog coherent optics, where the DSP is located on the line card itself. And on the right, we have the DCO for digital coherent optic, where the DSP is present on the optic module itself. This second option offering better flexibility, as we know that interoperability in this world can be a bit more challenging than in IP. Let's move to the features and answer the question of the support of BGP FlowSpec. Today, it's limited to systems based on Jericho Plus and Jericho 2 with OP and OP2 eTCAM. We plan to extend the support to non-eTCAM versions, but it's in a roadmap and it's not available today. So the support will be only for 55A1 36H SCS, 55A2 mode SCS for the fixed side, and in the chassis only the mode SC and the 36-port 100 gig ASC, and finally the 5718DD SC that can be used to program BGP FlowSpec ports. Alternatively, and only for specific use cases, we worked on a script running on the router and converting FlowSpec rules in access list entries dynamically. You can contact me if you want more details, and it's still a work in progress, but it can be useful. Let's try to answer the question of the support of MACsec. The NCS 5500 series, at least today, doesn't support IPsec but only MACsec. So it's a layer 2 encryption performed at line rate, and it does not affect the performance in terms of bandwidth or PPS. Today also, we only support it in point-to-point mode and not over pseudo-wires. So, which platform supports it? It's easy, just check the -S at the end of the product ID. MACsec is supported on all ports of the NCS 55A2 36H, SC or not, all ports of the MACsec line card of course, and the mode line cards, SC and non-SC, and all the CFP2 ports of the coherent line card. On the 55A1 40Q6H, we support it only on the 6-port 100 gig, and it's the same for the 24Q6HS, but also on the last 16 SFP ports. Finally, we support it on the 55A2 mode systems on the last 16 ports and all the MPAs. Note that it's supported for 100 gig and 10 gig, but not for 1 gig. For your reference, all is summarized in this chart. Which router supports timing technologies? Protocols like PTP and SYNCI. First, it will require a Jericho Plus NPU. Whether it's completed with an external eTCAM or not is not relevant, in this context at least. So all fixed systems based on Jericho Plus supports timing features. And so does the line cards in your chassis. Jericho Plus is mandatory, but in the chassis case, it's also mandatory to use a second or third generation of route processor, the RPE or RP2E. One exception only to this rule, the timing is also supported on the NCS 5501 SC, which is powered by a Qumran-MX. And here again, just for reference, a chart gathering all these details. The last angle I will take to compare all these routers is the form factor, and more specifically the depth. It may not be the first thing you may consider, but it's actually a very important parameter to keep in mind depending on the facility where you plan to rack your system. And this dimension varies significantly among the different routers of the family. The smallest one is the 55A2 mode, 28 centimeters. Then we have 55 centimeters for the 24Q6H, the 5501, and the A124, 68 centimeters for the 48Q6H, and finally the largest is the 5502 and the 55A136H with 76 centimeters. It's long and heavy, so pay close attention to these aspects or you may be unpleasantly surprised. So I hope you have now a pretty clear view of the portfolio and you are able to understand the NPU used, the route scale you can get, the bandwidth it offers, the different type of interfaces available, but also the features you can expect on each of these routers. I know it has been a long part, but it covers a large majority of the question I'm answering on a daily basis, so I hope it's going to be useful.